Okay, let's asked to do some problems here from 7-6. These are numbers 4 and 5 from the online work, and that corresponds to numbers 13 and 17 in the book. So we have, we're going to find mx, my, and x bar, y bar. So the moment about the x-axis and y-axis, and center of gravity for the lambdas of uniform density lambda. Not lambda, rho, bounded by the graphs of their equations y equals 1/8 x, y equals 0, and y equals 8. So first we'll find the mass. Mass will equal, it is a lambda, lowercase lambda, integral from 0 to 8 of our y equals 1/8x, so we just call the x over 8 dx, and that's going to be lambda x squared over 16 from 0 to 8, which is in lambda times 8 squared over 16 minus 0 squared over 16. 8 squared is 64. 64 divided by 16 is 4. So 4 lambda. Okay, I looked it up. That's a rho, not a lambda. Lowercase rho. Okay. Now our mx is going to be rho integral from 0 to 8 of, now this is going to be 1/8 x plus 0 divided by 2 times 1/8 x minus 0 dx. So it has the effect of being rho integral from 0 to 8, and we pull the 1/2 out there, times x over 8 squared dx, which we can call rho integral from 0 to 8. In fact, I might call that rho over 2 of x squared over 64 dx, which is rho over 2 times x cubed over 3 times 64 from 0 to 8. Okay, that's going to be rho over, get my handy dandy calculator here, (384) times 8 to the third power minus 0 to the third power. That's 512. Okay, so it's going to be 512 rho over 384, and we can reduce that to 4/3. So for the y bar, that's going to be mx over m, which is going to be 4/3 rho over 4 rho, and things cancel out nicely. The rho's go away, 4 there, and we're left with 1/3. Let's get the x bar. First we have to get my. That's going to be rho integral from 0 to 8 of x times, it's going to be x over 8 minus 0, which is just x over 8, So I could pull that 8 out here and call that x squared, because x minus 8, x over 8 minus 0 is just x over 8. So the 8 is out there. X squared dx, rho over 8 times x cubed over 3 from 0 to 8. So I could pull that 3 out as well. So it'd be rho over 24 times 8 cubed minus 0 cubed. So that's going to be 512 over 24 rho. And that reduces to be 64 over 3. So the x bar is my over m. That's 64 over 3 rho divided by 4 rho. Four reduces. That leaves us as a 16. So it's just, oh, I forgot the rows divide out. So it's just 16/3. So x bar, y bar, center of gravity, is going to be 1/3, no, 16/3, comma 1/3. Okay, I hope that helped. And the next one we're going to do here is find mx, my, and x bar, y bar for the lambdas of the uniform density rho, bounded by the graphs of the equations. Y equals x squared, kind of hard to see that, and y equals x to the 7th. Should we write those? Not much better. Okay, so again we have m equals rho integral of x squared minus x to the 7th dx, because the x squared is going to be the upper curve for the first part. We're going from, I guess we could look at this as x squared equals x to the 7th. When is that the case? That's whenever x squared minus x to the 7th equals 0. X squared times 1 minus x to the 5th equals 0. So that's where x squared equals 0, so x equals 0. And where 1 minus x to the 5th is 0, 1 equals x to the 5th, x equals 1. 5th root of 1 is 1. So we're going to go from 0 to 1, and in that interval x squared is going to be on top, because it really flattens out for the x to the 7th. Okay, and that's going to give us rho times x cubed over 3 minus x to the 8th over 8 from 0 to 1. And that's going to be rho times what? 1 to the 3rd power over 3 minus 1 to the 8th power over 8 minus, put in 0, you get a 0. So what we're looking at is 1/3 minus 1/8. Common denominator is 24, so it's going to be 8/24 minus 3/24. 8/24 minus 3/24, so that means we're going to have rho times 8 minus 3 is 20. It's 5/24. Okay, that's our m. Now we get to the interesting part. mx is going to be rho integral from 0 to 1, and it's going to be x squared plus x to the 7th over 2 times x squared minus x to the 7th dx. And so we can pull that 1/2 out, and I'll call that a rho over 2 integral from 0 to 1. So then we have basically an a plus b times a minus b, so that's going to be a squared minus b squared, or x to the 4th minus x to the 14 dx. So we have rho over 2 times what? X to the 5th over 5 minus x to the 15 over 15 from 0 to 1. That's going to be rho over 2 times 1 to the 5th over 5 minus 1 to the 15 over 15 minus 0. So it's rho over 2 times, it's basically 1/5 minus 1/15. That'd be rho over 2 times, that's 3/15 minus 1/15 is going to be rho over 2 times 2/15. Now it just reduces to become rho over 15. Then we get the my. I guess we can get the y before I go there. But y bar is going to be mx over m, which is going to be rho over 15 over 5 times rho over 24. So that's going to be 1/15 times 24/5 and a little bit reduces out of this, not much. And we can divide a 3 out of 24 and the 15, leaves a 5 down here, 8 up there. So we have 8 over 25. Now for the my, we have rho integral from 0 to 1 of x times our x squared minus x to the 7th dx, which is rho integral from 0 to 1 of x cubed minus x to the 8th dx, which will be rho times x to the 4th over 4 minus x to the 9th over 9 from 0 to 1. Boy, the 0 sure is nice in this problem. So we have rho times 1/4, or 1 to the 4, which is 1, minus 1 to the 9 over 9. That 9 looks really bad. Minus 0. So we have rho times 1/4 minus 1/9, which is rho times 9/36 minus 4/36, which is going to be rho times 5/36. Give myself another page to work with here. So our my is going to be 5 rho over 36. Therefore, x bar is going to be my over m, which is 5 rho over 36 divided by 5 rho over 24. So we have 5/36, the rows divide out, times 24/5. 24 over 36, that could be reduced by 12 to give us 2/3. So x bar, y bar is going to be 2/3, 8/25. Okay. Hope that helps.